Good, beautiful Thursday morning, everyone. It is another day for alphas to be working from home and quarantine. So, best of luck to you, and hope you're still feeling well and healthy. Let me know if I can help you if you need a Zoom today. Um, Same for Omega. I'll actually get to see you before I see the Alpha students again because Martin Luther King Jr. Day is Monday. So I'll see Omega next week on Tuesday, and then Alphas I won't see you until Thursday next week, which is kind of crazy. But you know that you can reach out to me via um, email, Schoology Messenger, or Zoom, and we can connect. I'm going to do a game of Pictionary next Wednesday if anybody wants to join that Zoom. But today is lesson 7. And yesterday I mentioned we skipped the word problem because there's going to be a lesson coming up that is all word problems. And it's today. In today's word problems, it's going to be two-step word problems. So, meaning that um, it's kind of a hint to you that if you only do one mathematical operation in the question, then you're kind of knowing you're already wrong. So let's go ahead and keep that in mind as we solve these. Let me minimize myself and let's get right into it. We're gonna go to the problem set because we're gonna do two of the word problems together, and then I will let you try two of them, and then you can go to your exit ticket. So um, they you guys know how the word problem or the problems on and not just word problems but the problems on these problem sets work. They work their way from kind of simplest to the most abstract, or uh, the easiest to the most challenging. So let's go ahead and do 2 and 4 together, which will leave you 1 and 3. So it just says solve the word problems using the read, draw, write strategy and show all your work. Now remember, reading, we're going to read it a couple times probably. When we go to draw, we could draw with our mathematical models. Sorry, I couldn't think of the word. I was like, but you could draw pictures. We can do the mathematical models, or we can show our mathematical numerations and mathematical sentences. So we can use um, just our math sentences and math expressions to show our drawing. And then when we write, that's where we write a statement for the question. So let's go ahead and go through that process together. Jing spent 1/3 of her money on a pack of pens, 1/2 of her money on a pack of markers, and 1/8 of her money on a pack of pencils. What fraction of her money is left? Okay, well, let's think about that. So we know that she has one whole that they're using or that she's starting with. We don't know what that one whole is. It could be $1, it could be $10, it could be $100. Doesn't matter what the whole is, except we know that that whole is being broken into parts, and we got 1/3, 1/2, and 1/8. So how do we start with this? Well, on this, we're just going to use a tape diagram, kind of, and we're going to give it those chunks. We know that, and we're going to just try our best with it, but we're going to label it so that we know what they're supposed to mean. We know that that's a pack of pens is going to be 1/3. The pens is 1/3. You don't have to write the pens in the middle. A half, so I'm going to make that a little larger, and that's 1/2, and that's going to be her markers. So I'll just put M in there for markers, and then 1/8. Oops, I don't. I got to make that a smaller section. This one being 1/8, and then this is a question mark. We don't know what's left over. Okay, so now we can visualize it. This is pencils in here. So we have 4 chunks, but um, we don't know what it should be. We have thirds, halves, and eighths. So what do we do? We know one whole is the same number of pieces as the number of overall units. So what do we change it to? Yeah, so we have to figure out a common unit for all of these. So first, let's find the largest digit unit, or the smallest piece, which would be eighths. And let's just count over here by eighths. 8, 16, 24, and 32. And then let's count by threes. I'm going to change color so it's a little easier to see. 3, 6, 9, 12, 15, 18, 21, 24. Okay, so they both have a 24. Now the question has to be, does that work for our third fraction? So we've done eighths, we've done thirds, and we are now doing halves. And we know that halves can go into anything even. So the question is, well, let's go ahead and convert these into 24ths. So we could draw our models and cut them apart, but we're just going to show the transition from thirds, halves, and eighths to the 24ths numerically. So we're going to just show it. So we need 3 little sentences. Let's start with 1/8. Well, we know that 1/8, we want it to be equal to 24ths. So this is, you kind of set it up and you can see for your brain, what did you do to 8 to get to 24? Well, we counted by our multiples and it's 3 groups. So we multiplied it by 3. So what do we do to the bottom? We do to the top. So 1 times 3 is 3. So we know that our 1/8, our money for our pencils was really 3/24ths. Let's do the same thing for 1/3. Now 1/3, we know, again, the common unit is going to be 24ths. So what did we do to get thirds to 24ths? Well, we multiplied by 8. Whatever we do to the bottom, we want to do to the top. And 1 times 8 is going to become 8. So we have 8/24ths for 1/3. And we'll do one more, 1/2. Some of us, because it's halves, will already be able to visualize it because you're like, well, what's half of 24? Well, that's a smart way to think, but just to prove it numerically, well, what times 2 gives us 24? Well, that's 12. Well, then I have to do that same thing to the top. 1 times 12 is 12. So here we go. Now we have our pieces as a common unit. So we need to subtract those 3 from 1 whole to find out what the fraction is left. So I'm going to first add my 3 new fractional pieces of 24ths. So I'm going to add those together. So let's go ahead, 12 24ths plus 3 24ths plus 8 24ths. And that's going to give us, well, 8 and 12 gives me 20. And then 3 more is 23 24ths. So I don't even think we need to set it up to subtract to show what's left, because I think we can all see it. To get to 1 whole of 24ths, it's 24 24ths, right? How many would be left? Well, hopefully you could see it. I'm going to write it down. 24 24ths minus 23 24ths. Well, our answer should be 1/24. So now this is why it's so important to write a statement for your answer. If you just looked at this without following my work, do you know where the answer is? You're like, whoa, where is it, Mr. Briggs? One of the reasons why we ask you to write a statement. I better make sure my font is the right size. Let me get to 14. And the statement is going to be, I gotta change my color font. It's on white right now. Jing would have 1. I'm going to just give space to write that money left. And the reason why I did space, because the fraction when you're typing isn't as easy. So 1/24, I'll just write it in there. So good. All right, let's get on to the next question. Before we move on to the back, I'd like you to pause me and try question 1. Let me read it for us and I can help your brain get thinking about it. George weeded 1/5 of the garden, and Summer weeded some too. When they were finished, Summer, you can tell, is a person. When they were finished, 2/3 of the garden still needed to be weeded. What fraction of the garden did Summer weed? Well, that's an interesting question. So we know that there's one whole garden to be worked on. We know that George, and I'll just put a George G in here for George, did 1/5. Whoops, that's a half. Mr. Briggs, 1/5. And we know that 2/3 of it still needed to be finished. But we don't know what Summer did. We don't know the fraction that Summer did. So this is one of the, let me make sure that this is 1/5 over here. This is one of the great reasons why we like to draw a little model to represent the question, because now it's like, okay, I can see what we need to do. We need to create common units and then subtract it from one whole to find what we have. All right, so go ahead and pause me and see what you can do from there. All right, welcome back. Let's take a look at our work. The common unit was 15ths. So you can see my conversion right here. You multiplied fifths by 3 and thirds by 5 to get 15ths. I added those pieces together and then subtracted from one whole to see that there's only 2 15ths left, which is what Summer weeded inside of the garden. All right, nice job. So let's go to the back page now. Let's go ahead and do question 4 together. And then again, I'll read question 3 for you, and we can then go ahead and try doing that one. All right, so Jim sold some lemonade. Oh, I think is there another question on this? A third page? Oh, there's a third page. We're only going to do 4 questions, though. Don't worry about question 5. All right. Jim sold 3/4 gallons of lemonade. Dwight sold some lemonade too. Together, they sold 1 5/12 gallons. Ooh, together. So, all right. Who sold more lemonade, Jim or Dwight? How much more? Okay, so really right now we got fourths and we got 12ths, so they don't really work together. So hold on, let's think about this. There's more than one way to solve this question, so don't, in terms of how you approach it, I shouldn't, the math is going to be the same. We're still going to create common units and work with those common units to find the answer. Well, we know that the whole is 1 5/12, and that Jim, so this one's a hard model to show. It's like we have Jim, and then we have Dwight. We don't know what Dwight sold, but we know that Jim is 1 and, we know Jim is 3/4 of a gallon, and we know all together that it's 1 5/12 of a gallon. So we can kind of visualize that we either need to figure out what we need to add to 3/4 to get to the total, or we could subtract 3/4 from that to see what we get. So I always like to take it away. So 12ths and 4ths. So we got to think what could be the common unit. So if we counted by 12s, 12, 24, are either of those a multiple of 4? So the question I'm asking is, can 4 be divided evenly into 12 or 24? The answer is actually both of them, right? 4, 8, 12, 16, 20, 24. So it's actually both of them. Well, it's always best to use the smallest common unit. So let's convert these into 12. So, 1 5/12 is already 12s, but how do we, let's convert 3/4 to 12s. Well, what did we do to the bottom to get to 12s? We multiplied by 3. So the top 3 times 3 is going to give us 9. Great. Well, we have 1 5/12 minus 9/12 now. So when we think about this new math expression that we just wrote, 1 5/12 minus 9/12, do we have enough 12ths to take 9 away from as is? Well, no, right now we can't take 9/12 away from 5/12, but we do know that we can regroup that one whole, sorry, I didn't really hit the circle perfect, is 12/12. So if I put 12/12 and 5/12 together, I'm really looking at 17/12 minus 9/12. And that should give us what's 17 minus 9 is 17 apples minus 9 apples is always going to give us 8 apples. And so we keep our unit as 12ths. So now if we think about this, we knew that 3/4 is equal to 9/12, and we know that Dwight had 8/12. Now the question is, who sold more? And then the question was, how much more? So we got to have both pieces. Well, Jim, 9/12, Dwight, 8/12. So if we wanted to prove how much more, we just show a little quick subtraction. 9 minus 8 is always going to be 1. So 9/12 minus 8/12 is going to be 1/12. So now we know that somebody sold more. Who sold more? Well, that was Jim with 9/12, and he sold 1/12 more. So now we just got to write that statement. So let me get my typing tool because it'll be a little easier right now. So Jim sold, and we can answer both questions in one, and we can say, I'm going to give myself space. Jim sold blank more than Dwight. So now we can say, we're saying who sold more and how much more in one simple sentence and not having to write two. Well, how much more was it? Well, it was, whoops, give me my pen tool back. It was 1/12 more. 1/12 of what more? Actually, I should have been a little bit more specific. 1/12 of, and I believe it was gallons. Let's just go back up, and it was 1/12 gallons more. Let's be a little bit more specific. Great. Bronson is whining to go out, so let me go ahead and let him out. All right, let's go look at question 3 together. All right, Shelby bought a 2-ounce tube of blue paint. She used 2/3 ounce of a paint to paint the water. 2 ounces of the paint or 2 ounces to paint the sky, and some to paint the flag. After that, she had 2/15 ounce left over. How much paint did she use to paint her flag? Whew. Okay, that's one of the, again, these word problems are quite involved. So we got, looks like there was, out of our whole, we know that there's 2/15 left over. We know that we don't know what the airplane was, or the flag was. Airplane, I don't know where I got that. 2/3 was for water, and 3/5 was for the sky. We don't really know what the whole was, so how do we do this? I'm sorry. I completely forgot that first. I had to reread the sentence. I was like, that won't make sense. How do we figure this out? But that first line, we're working out of a 2-ounce, so 2 holes, tube of blue paint. So we're working from 2 holes, and we have 2/3 of it being water, 3/5 for the sky, 2/15 for the leftover. Let me write that leftover. And then we just don't know what for the flag. So let's go ahead and think about common units, because right now we got thirds, we got fifths, and we got 15ths. So if we think about our the smallest piece unit, which is the largest digits, the largest numerical, it's hard to say because it's not the largest unit, right? Because 15ths are the smallest pieces. So that's where I get a little clunky when I'm talking about it. But the largest number representing our units. So 15th is our largest units. If we counted by 15ths, 15 15ths, 30 15ths, so 15 and 30, we have to ask ourselves, are any of those multiples of 5 and 3? Well, 5, 10, 15. Yep, that works for 15. 3, 6, 9, 12, 15. Yeah, 15ths is going to be our common unit. So let me just help you think about that real quick before I let you unleash. So we got 2/3, we had 3/5, and we have 2/15. And we want those all to be 15ths. Well, 15ths is already there, so we're just going to leave that as is. And I just want you to think about, what did you do to the bottom? Oops, that's a ×3, not a ×5. And help you from there. Now, once you get those common units, I'm hoping that you'll be able to solve from this. You're taking it away from 2 wholes. All right, so, okay, pause me and I'll be back soon. All right, welcome back. So you can also see after I did my conversions of creating equivalent fractions, 2/3 was 6/15. That is wrong. So my answer is wrong. I just noticed that my question was wrong. That shouldn't be 6/15. I multiplied it by the wrong. That should be 10. Okay, so I'm gonna help fix my mistake right now. So this is 10/15. That's 9. So I have to go back here. But remember, even if you make a mistake like that, you get credit if you continue to do the rest of the math the right way. You won't get full credit, but this should have been 10. So that changes my answer. 10 plus 9 is 19, plus 2 more is 21. Okay, so now it's 30 minus 21. It's not 13/15. That would be 9. So let me fix my answer over here. Shelby used 9/15 ounces of paint to paint her flag. But it's important to check your work. Let's just check the rest of the work to make sure I didn't make any more mistakes. 3/5 is 9/15. There's our 2/5 of leftover, right? And then, because I know I needed to subtract it from 2 wholes, I converted 2 wholes into 15. So 15/15 plus 15/15 is 30/15. So you can see my 3 fractions that I converted into 15ths. I added them there. And then right below it, I subtracted it from 2 wholes to leave us with 9/15. And then I have my statement down below. All right, it's time for your exit ticket. Let's just, here, let me look at it real quick. Let's look at it quick together. I don't think a lot of us stick around this long for the videos, so that's okay. So let's quickly, lesson 7. It's one word problem, multiple steps. Mr. Pham mowed 2/7 of his lawn. His son mowed 1/4 of it. Who mowed most, and then how much lawn still needs to be mowed. All right, so good luck. Let me know if you need help today. I'll be by my computer all day, so just give me a shout. All right, guys, have a great day.